Today we are just going to talk about the safety instrument system, which involves a final shutdown valve along with a solenoid valve. Generally, a final shutdown valves remain in a static, one uniform condition for a long operational period unless it is demanded to act during the safety demand. So there has been technology implementation available through using the microprocessor-based device to check the integrity of the final shutdown valves, which is a mechanical integrity, and that's a great thing. But what happens, the solenoid valve, which is attached to it for taking the valve to safe state, is never being checked. The reason being, the solenoid valves are de-energized to trip, which means when a safety demand comes, the solenoid valve will trip on its own by de-energizing. So during partial stroke tests, when we check the integrity of the mechanical valve body and actuator, we forget about the solenoid valve because that acts just like is a piece of pipe. Solenoid valve has mainly two failures. One is the coil burning, another one is the plunger stuck. The coil burning is a very obvious one. The moment the coil burns, the solenoid valve de-energizes and there will be a spurious trip during the normal operation. The one which is hidden and dangerous undetected is the plunger stuck. Though the solenoid is operating, but we don't know whether the plunger moves during the safety demand or not. So there has been a concern in the industry. Partial stroke test has been there for so many years, but nobody thought about the final element along with the solenoid valve, which has never been tested during this shutdown activity. So now these microprocessor intelligent devices not only check the integrity of the valve body and actuator, but can also check the solenoid plunger health by pulsing solenoid for a millisecond, which is short enough to not make any process disturbance, but at the same time large enough to improve the safety reliability of the safety instrumented function loop. Out of the final element total failure, 30% of the failure resides within the solenoid valve. So by doing this health monitoring, additional check improves safety reliability, which is a key and critical part of the safety instrument function loop, which makes a plant much more safer, efficient, and reliable. So by checking the SOV health monitoring, they're getting peace of mind, but at the same time, they're getting a deterministic test results through their host and associated software called IAMS, Intelligent Asset Management System, and that will be a documented results allowing them for any insurance company or any auditor or any regulatory bodies to check that these things have been tested as per the schedule or as per the proof test requirement to meet the validation and verification as guided in the IEC 61511 safety life cycle. SOV health monitoring is a critical part of your safety instrument function loop, and if you have any questions, please post it on Emerson 365